In this voiceover video, I'm going to explain how to find the Marshallian demands for x1 and x2 when you have a utility function that's a Cobb-Douglas. So first of all, you should be able to recognize what is Cobb-Douglas functions, something like we have here. This is somewhat similar to your problem on the problem set for 2 through 4, number 7. So let's get into it. And first, I want to say that this one's much more difficult. The one on your problem set is a little bit easier. So let's get into it. So we have this utility function, and we also have a budget, which we don't have numbers for, but just P1x1 plus P2x2 equals M. That's always what we're going to have for our budget. So when we're doing utility maximization, we always want to set marginal rate of substitution, MRS, equal to the MRT, marginal rate of transformation. So the marginal rate of substitution has to do with the partials from the utility function, partial derivatives, and the MRT is just P1 over P2. So that part's easy. Now the MRS, remember you can use that Cobb-Douglas shortcut or trick. It's the first exponent and the second variable, x2. x2 is always going to be on top over the second exponent times x1. So we have 3x2 over 4x1 equals P1 over P2. Now we want to get it out of these fractions to make it much just easier for us to work with. So we can cross multiply both of these. So we'd have 3p2 x2 equals 4p1 x1, right? So we have one equation here. I'll call it number 1. And I'm going to use the budget for the second equation. We have an equation here for number 1 where it has 2 unknowns in it. We need to use a second equation of some sort to be able to find what x1 and x2 actually are. So second variable is p1x1 plus p2x2 equals m. And I said variable, but the other equation is the budget. Now we want to be able to substitute something from maybe 1 into 2. You can do it the other way too as well, but I'm going to do that. I'm going to do the first way. So maybe I'll get P1x1 by itself and then substitute it into here. So P1x1 from number 1 equals 3/4 P2 x2. And I'm sorry about my stylus. I need to get, well, I ordered a new one, so I'm just waiting for that. This one's not too great on the touchscreen. All right, so we have this. And so let's replace what we know for P1x1, this 3/4 P2 x2. I'm leaving it in fractions just so I don't have a problem when I have to round. This, comes out nicely, but you might get a number that doesn't come out as nicely. So in the budget equation, I'm going to put 3/4 P2x2 in for P1x1. So combining the two equations, we have 3/4 P2 x2 plus P2 x2 equals m. So these P2 x2s we can add together. The second one here, this is just, one P2 x2, or we can think of it as a fraction with that equals 1, so we can think of it like 4/4 to get it just to have the same denominator in the coefficient. So then we add straight for the numerator, 3 plus 4 is 7/4 P2 x2 equals m. Now we're close. We want to get x2 by itself. So if we divide everything out from the left-hand side, divide the 7/4 times the P2, we're going to have x2, and I'm going to call it a star because that means we have the answer, and this is one of those. So this equals definitely m/P2. But remember the fractions flips, so it's 4/7. This is where I mentioned that it's probably good to keep fractions just because of rounding. 4/7 is not going to come out nicely. But, if you do round and you show me, that is fine as well. All right, so we have x2, but we just need to find x1. So you can plug what we just got for x2 into one of the two equations that we have. I'm going to plug it into 1 because I think that's going to be a little bit easier. Not, it doesn't have to be, but I think that's going to be better than the second one. So we know 3p2. Now for x2, I'm putting in what we just found, 4/7m/p2, and that equals 4p1 x1. So kind of a mess, I know. Let us cross out these p2s. And we have 3 times 4 is 12/7 times m equals 4p1 x1, right? So we want to get x1 by itself, and we just have to divide again. So again, I said this problem has some more math in it. It's a little bit more difficult than what you have on your problem set, which is nice. Should be nice for you. So I'm running out of room. I can erase the first part, but I'm going to try to fit it here. And I'm going to put x1 on this side. So I'm switching it up, but just switching the equations around. We have x1, and we want to divide each side by 4 times p1. So we'd have 12/7 m/4p1. And you can leave it like this, but to maybe get it a little nicer, we can divide the top and the bottom by 4. This 4 on the denominator goes away, and we're left with just a 3 on top. So x1 star equals 3/7 m/p1. So now we have both of the x's, and these are what we call the Marshallian demands. These are the solutions to our utility maximized problem if we knew what m and the prices were. Remember, this is a 7, doesn't look like it. All right, now I'm going to maybe erase some of this just so I can talk about some of this that we've been going over. Let's see. Eraser. I don't know what color it's going to go to. Let's see. Oh, this is weird. Sorry, everyone. Let's just go to a new page. And I will write down what we had. So still seem to have not enough coffee ever. Okay. What are we doing? X1 star. That was that 3 over 7, M over P1, and X2 star. It's 4 over 7, M over P2. So again, if we actually had numbers for the budget or income, M, or the prices, we can get an actual value. But this is fine for us. This represents the amounts of the two goods, no matter what the prices or the incomes are. So what else can we say? First of all, I want you to notice that in each of these equations, there's not the other variable. Like we don't have an x1 over here. We don't have an x2 over here. And that just means that they're separate. They also don't have each other's prices. So like we don't have a P1 for x2. We don't have a P2 for x1. So they're completely separate from one another. All that really matters is this, these fractions, these coefficients that tells us kind of how much of the budget we're going to get for each good. And then we have just M over the prices. So again, independent of one another. All right, hope this helped everyone. Let me know if you have any questions. Hopefully you're working on these soon. Have a great